Module 1, Lecture A, Introduction to the Course. Imagine being able to look at a messy spreadsheet, a stream of user actions, or a set of past decisions and say, I can turn this into a working prediction system, and I understand what it's doing. This course is designed to take you from curiosity about machine learning to a grounded, practical understanding of how modern ML systems are framed, built, evaluated, and monitored. You'll start with an intuitive picture of how machines learn from data instead of fixed rules, and gradually connect that intuition to the concrete tools, checks, and decisions that make real-world models useful and trustworthy. No specific background is assumed beyond basic comfort with numbers and a willingness to think carefully about data and its consequences. Across 10 modules, you'll first map out the main types of machine learning: supervised, unsupervised, and reinforcement, and practice judging when learning from data makes sense compared with handcrafted rules. You'll learn how to read and question datasets, distinguish features from targets, and define clear prediction questions. From there, you'll interpret linear models and probabilities, fit and critique regression lines, and quantify errors using loss functions and gradient descent. You'll compare models with meaningful metrics for both regression and classification, split data into training, validation, and test sets, and prevent leakage while cleaning, imputing, and scaling features. As relationships grow more complex, you'll extend linear models with curved and interaction terms, explore simple rule-based models, and then move into clustering and distance-based thinking to uncover structure in both low and high-dimensional data. Finally, you'll examine how bias enters ML systems, run basic fairness checks, and place all these technical pieces inside an ethical, end-to-end ML lifecycle. By the end of the course, you'll be able to look at a prediction problem, frame it clearly, choose appropriate data and features, train and tune baseline models, and judge their performance with metrics that actually match real-world stakes. You'll know how to spot overfitting, data leakage, and misleading accuracy, how to interpret clusters and projections without overclaiming, and how to surface and communicate limitations and fairness concerns. Most importantly, you'll leave with the confidence to participate in machine learning projects, asking sharper questions, making more informed decisions, and feeling equipped to keep learning as you encounter new models, tools, and domains. Thank you for your attention. See you all in the next lecture.